The last time this object came near the sun, human civilization barely existed. There were no cities like ours, no telescopes, no satellites, no NASA, just Earth, the sky, and a frozen object falling in from the farthest darkness of the solar system. Then, after thousands of years, Vera Rubin caught it again, a faint moving point, a visitor on an orbit so long that one trip around the sun could take 10,000 years. And now the question is terrifyingly simple. What has been waiting in the darkness since before history began? This matters because an object with a 10,000-year orbit is not just another comet. It may be a fossil from the edge of a solar system, a frozen remnant that has spent almost all of human history far beyond the planets. Rubin is designed to repeatedly scan the southern sky and catch objects that move or change. And in its first public imagery, it discovered 2014 new asteroids in just over 10 hours of test observations. If Rubin can catch objects this faint and slow, then the solar system's oldest visitors may finally stop arriving as surprises. They may start arriving as warnings from deep time. The object was not shocking because it was bright. It was shocking because it was old. Not old like a mountain. Not old like a fossil in the ground. Older than memory. Older than every city on Earth. Older than every telescope ever built. If its orbit really takes around 10,000 years, then the last time this object came close to the sun, human history looked almost nothing like it does now. There were no space agencies, no rockets, and no written astronomy as we know it. No one could calculate its path. No one could name it. No one could know it would come back. It passed through the inner solar system, vanished into the deep, and then spent thousands of years falling away from us, far beyond the planets, far beyond Neptune, far beyond the places where sunlight still feels strong. And then, after all that time, it began falling back. That is what makes this object different. A normal asteroid may orbit the sun every few years. Halley's Comet returns about once in a human lifetime. But a 10,000-year visitor is not part of human time. It belongs to deep time, the kind of time where civilizations rise and disappear before the object completes one loop around the sun. And Vera Rubin was built for exactly this kind of discovery, not because it stays at one target forever, but because it watches the sky change. Rubin's legacy survey of space and time is designed to take hundreds of images of the southern sky every night for 10 years, building a record of objects that move, change brightness, or appear where nothing was visible before. That is the first key. Rubin does not treat the sky like a picture. It treats the sky like a crime scene. Every night leaves evidence. Every point of light has a position. Every position can be compared. And when one tiny object moves against the stars, Rubin can catch it. At first, it may look like nothing, a faint dot, a cold speck, one pixel among millions. But then it shifts. Not much, just enough. And that tiny movement tells astronomers something huge. This object is not a star. It is inside our solar system. It is moving under the sun's gravity. It has a path. And if that path is stretched enough, it may point back to the farthest reservoir of icy bodies around the sun. NASA describes the Oort cloud as a distant, there-iced shell of icy objects surrounding the solar system, with its inner edge thought to begin thousands of astronomical units from the sun. That distance is almost impossible to feel. Pluto orbits between about 30 and 50 astronomical units from the sun. The inner Oort cloud may begin thousands of astronomical units away. That means an object from there spends almost all of its life in darkness. The sun is not a blazing disk anymore. It is just one bright star among others. The planets are tiny. Earth is invisible, and yet gravity still holds the object barely. For thousands of years, it drifts through the cold. Then something changes. Maybe the slow pull of the galaxy. Maybe a passing star long ago. Maybe a gravitational nudge that happened before recorded history. The object's orbit shifts, and it begins the long fall inward. Not fast at first. Not dramatic. Just a frozen body moving through darkness toward the sun. And this is the conflict. When Rubin catches it, we are not seeing the whole journey. We are seeing one brief chapter. A few nights, a few positions, a faint motion. From that tiny arc, scientists must calculate an enormous orbit. Where did it come from? How close will it get? How long is its period? Is it truly returning after 10,000 years? Or is this its first recorded visit? Because long-period objects are dangerous to understand, not necessarily dangerous to Earth. Their orbits are huge. Their paths can be changed by planets. Their measurements need time. A small error near Earth can become a massive uncertainty thousands of years from now. So the number 10,000 years is not just a label. It is a warning about scale. It tells us we are dealing with an object whose story is bigger than human records. The consequence is simple. Rubin did not just find a dot. It may have caught a messenger from the edge of the solar system, a frozen object that has spent nearly all of human civilization in darkness, returning now with material from a place we have never visited and may never see directly. And if Rubin can find one of these visitors early, then the next one may not arrive as a surprise. It may arrive with a track, a name, an orbit, and time for the world to watch. So, the first revelation is this: the object is not terrifying because it is close. It is terrifying because it is ancient. But the next question is even stranger. If something appears only once every 10,000 years, what could have pushed it toward the sun right now? A 10,000-year orbit does not happen by accident. It means the object is on a stretched path, a path so long that most of it lies far beyond the planets. For thousands of years, the object is almost invisible. No tail, no glow, no dramatic coma around it. Just ice, dust, rock, and darkness. Then it begins moving inward. Slowly, the sun grows brighter. The temperature rises. Frozen gases that have slept for thousands of years begin to wake up, and the object starts changing. This is why long-period comets are so valuable.